12345++, fast single image to 3D objects with consistent multi-view generation, and 3D diffusion. Recent advancements in open-world 3D object generation have been remarkable, with image-to-3D methods offering superior fine-grained control over their text-to-3D counterparts. However, most existing models fall short in simultaneously providing rapid generation speeds and high fidelity to input images, two features essential for practical applications. In this paper, we present 12345++, an innovative method that transforms a single image into a detailed 3D textured mesh in approximately 1 minute. Our approach aims to fully harness the extensive knowledge embedded in 2D diffusion models and priors from valuable yet limited 3D data. This is achieved by initially fine-tuning a 2D diffusion model for consistent multi-view image generation, followed by elevating these images to 3D with the aid of multi-view conditioned 3D native diffusion models. Extensive experimental evaluations demonstrate that our method can produce high-quality diverse 3D assets that closely mirror the original input image. For more information, please visit the project's website. Instant 3D, Instant Text-to-3, Degeneration, Text-to-3D generation, which aims to synthesize vivid 3D objects from text prompts, has attracted much attention from the computer vision community. While several existing works have achieved impressive results for this task, they mainly rely on a time-consuming optimization paradigm. Specifically, these methods optimize a neural field from scratch for each text prompt, taking approximately 1 hour or more to generate one object. This heavy and repetitive training cost impedes their practical deployment. In this paper, we propose a novel framework for fast text-to-3D generation, dubbed Instant 3D. Once trained, Instant 3D is able to create a 3D object for an unseen text prompt in less than 1 second with a single run of a feed-forward network. We achieve this remarkable speed by devising a new network that directly constructs a 3D triplane from a text prompt. The core innovation of our Instant 3D lies in our exploration of strategies to effectively inject text conditions into the network. Furthermore, we propose a simple yet effective activation function, the scaled sigmoid, to replace the original sigmoid function, which speeds up the training convergence by more than 10 times. Finally, to address the Janus multi-head problem in 3D generation, we propose an adaptive perp-neg algorithm that can dynamically adjust its concept negation scales according to the severity of the Janus problem during training, effectively reducing the multi-head effect. Extensive experiments on a wide variety of benchmark datasets demonstrate that the proposed algorithm performs favorably against the state-of-the-art methods, both qualitatively and quantitatively, while achieving significantly better efficiency. The project page is at the project's website. MART, Improving LLM Safety with Multi-Round Automatic Red Teaming. Red teaming is a common practice for mitigating unsafe behaviors in large language models, LLMs, which involves thoroughly assessing LLMs to identify potential flaws and addressing them with responsible and accurate responses. While effective, manual red teaming is costly, and existing automatic red teaming typically discovers safety risks without addressing them. In this paper, we propose a multi-round automatic red teaming, MART method, which incorporates both automatic adversarial prompt writing and safe response generation, significantly increasing red teaming scalability and the safety of the target LLM. Specifically, an adversarial LLM and a target LLM interplay with each other in an iterative manner, where the adversarial LLM aims to generate challenging prompts that elicit unsafe responses from the target LLM, while the target LLM is fine-tuned with safety-aligned data on these adversarial prompts. In each round, the adversarial LLM crafts better attacks on the updated target LLM, while the target LLM also improves itself through safety fine-tuning. On adversarial prompt benchmarks, the violation rate of an LLM with limited safety alignment reduces up to 84.7% after 4 rounds of MART, achieving comparable performance to LLMs with extensive adversarial prompt writing. Notably, model helpfulness on non-adversarial prompts remains stable throughout iterations, indicating the target LLM maintains strong performance on instruction following. Technical report. Large language models can strategically deceive their users when put under pressure. We demonstrate a situation in which large language models, trained to be helpful, harmless, and honest, can display misaligned behavior and strategically deceive their users about this behavior without being instructed to do so. Concretely, we deploy GPT-4 as an agent in a realistic simulated environment where it assumes the role of an autonomous stock trading agent. Within this environment, the model obtains an insider tip about a lucrative stock trade and acts upon it despite knowing that insider trading is disapproved of by company management. When reporting to its manager, the model consistently hides the genuine reasons behind its trading decision. We perform a brief investigation of how this behavior varies under changes to the setting, such as removing model access to a reasoning scratchpad, attempting to prevent the misaligned behavior by changing system instructions, changing the amount of pressure the model is under, varying the perceived risk of getting caught, and making other simple changes to the environment. To our knowledge, this is the first demonstration of large language models trained to be helpful, harmless, and honest, strategically deceiving their users in a realistic situation without direct instructions or training for deception. DiLoCo, Distributed Low Communication Training of Language Models. Large language models, LLM, have become a critical component in many applications of machine learning. However, standard approaches to training LLM require a large number of tightly interconnected accelerators, with devices exchanging gradients and other intermediate states at each optimization step. While it is difficult to build and maintain a single computing cluster hosting many accelerators, it might be easier to find several computing clusters, each hosting a smaller number of devices. In this work, we propose a distributed optimization algorithm, distributed low communication, DiLoCo, that enables training of language models on islands of devices that are poorly connected. The approach is a variant of federated averaging, where the number of inner steps is large, the inner optimizer is Adam W, and the outer optimizer is Nesterov momentum. On the widely used C4 dataset, we show that DiLoCo on 8 workers performs as well as fully synchronous optimization while communicating 500 times less. DiLoCo exhibits great robustness to the data distribution of each worker. It is also robust to resources becoming unavailable over time, and vice versa, it can seamlessly leverage resources that become available during training. A survey on language models for code. In this work, we systematically review the recent advancements in code processing with language models, covering 50-plus models, 30-plus evaluation tasks, and 500 related works. We break down code processing models into general language models represented by the GPT family and specialized models that are specifically pre-trained on code, often with tailored objectives. We discuss the relations and differences between these models and highlight the historical transition of code modeling from statistical models and RNNs to pre-trained transformers and LLMs, which is exactly the same course that had been taken by NLP. We also discuss code-specific features such as AST, CFG, and unit tests, along with their application in training code language models, and identify key challenges and potential future directions in this domain. We keep the survey open and updated on GitHub repository at project's website. Fast chain of thought. A glance of future from parallel decoding leads to answers faster. In this work, we propose FastCot, a model-agnostic framework based on parallel decoding without any further training of an auxiliary model or modification to the LLM itself. FastCot uses a size-varying context window, whose size changes with position to conduct parallel decoding and autoregressive decoding simultaneously, thus fully utilizing GPU computation resources. In FastCot, the parallel decoding part provides the LLM with a quick glance of the future composed of approximate tokens, which could lead to faster answers compared to regular autoregressive decoding used by causal transformers. We also provide an implementation of parallel decoding within LLM, which supports KV cache generation and batch processing. Through extensive experiments, we demonstrate that FastQT saves inference time by nearly 20%, with only a negligible performance drop compared to the regular approach. Additionally, we show that the context window size exhibits considerable robustness for different tasks. Qwen-Audio, advancing universal audio understanding via unified large-scale audio language models. Recently, instruction-following audio language models have received broad attention for audio interaction with humans. However, the absence of pre-trained audio models capable of handling diverse audio types and tasks has hindered progress in this field. Consequently, most existing works have only been able to support a limited range of interaction capabilities. In this paper, we developed the Qwen-Audio model and address this limitation by scaling up audio language pre-training to cover over 30 tasks and various audio types, such as human speech, natural sounds, music, and songs, to facilitate universal audio understanding abilities. However, directly co-training all tasks and datasets can lead to interference issues, as the textual labels associated with different datasets exhibit considerable variations due to differences in task focus, language, granularity of annotation, and text structure. To overcome the one-to-many interference, we carefully design a multitask training framework by conditioning on a sequence of hierarchical tags to the decoder for encouraging knowledge sharing and avoiding interference through shared and specified tags respectively. Remarkably, Qwen-Audio achieves impressive performance across diverse benchmark tasks without requiring any task-specific fine-tuning, surpassing its counterparts. Building upon the capabilities of Qwen-Audio, we further develop Qwen-Audio Chat, which allows for input from various audios and text inputs, enabling multi-turn dialogues and supporting various audio central scenarios. Fine-tuning language models for factuality. The fluency and creativity of large pre-trained language models, LLMs, have led to their widespread use, sometimes even as a replacement for traditional search engines. Yet language models are prone to making convincing but factually inaccurate claims, often referred to as hallucinations. These errors can inadvertently spread misinformation or harmfully perpetuate misconceptions. Further, manual fact-checking of model responses is a time-consuming process, making human factuality labels expensive to acquire. In this work, we fine-tune language models to be more factual, without human labeling and targeting more open-ended generation settings than past work. We leverage two key recent innovations in NLP to do so. First, several recent works have proposed methods for judging the factuality of open-ended text by measuring consistency with an external knowledge base or simply a large model's confidence scores. Second, the direct preference optimization algorithm enables straightforward fine-tuning of language models on objectives other than supervised imitation, using a preference ranking over possible model responses. We show that learning from automatically generated factuality preference rankings, generated either through existing retrieval systems or our novel retrieval-free approach, significantly improves the factuality, percent of generated claims that are correct, of Llama 2 on held-out topics compared with RLHF, or decoding strategies targeted at factuality. At 7B scale, compared to Llama 2 chat, we observe 58% and 40% reduction in factual error rate when generating biographies and answering medical questions, respectively. The art of LLM refinement. Ask, refine, and trust. In recent years, large language models, LLMs, have demonstrated remarkable generative abilities, but can they judge the quality of their own generations? A popular concept, referred to as self-refinement, postulates that LLMs can detect and correct the errors in their generations when asked to do so. However, recent empirical evidence points in the opposite direction, suggesting that LLMs often struggle to accurately identify errors when reasoning is involved. To address this, we propose a reasoning with refinement objective called ART, Ask, Refine, and Trust, which asks necessary questions to decide when an LLM should refine its output, and either affirm or withhold trust in its refinement by ranking the refinement and the initial prediction. On two multi-step reasoning tasks of mathematical word problems, GSM 8K, and question answering, strategy QA, ART achieves a performance gain of +5 points over self-refinement baselines, while using a much smaller model as the decision maker. We also demonstrate the benefit of using smaller models to make refinement decisions as a cost-effective alternative to fine-tuning a larger model. Instruction following evaluation for large language models. One core capability of large language models, LLMs, is to follow natural language instructions. However, the evaluation of such abilities is not standardized. Human evaluations are expensive, slow, and not objectively reproducible, while LLM-based auto-evaluation is potentially biased or limited by the ability of the evaluator LLM. To overcome these issues, we introduce instruction following eval, IFEVAL, for large language models. IFEVAL is a straightforward and easy-to-reproduce evaluation benchmark. It focuses on a set of verifiable instructions such as write in more than 400 words and mention the keyword of AI at least 3 times. We identified 25 types of those verifiable instructions and constructed around 500 prompts, with each prompt containing one or more verifiable instructions. We show evaluation results of 2 widely available LLMs on the market. Our code and data can be found at the project's website. Frontier language models are not robust to adversarial arithmetic, or what do I need to say so you agree 2 + 2 = 5. We introduce and study the problem of adversarial arithmetic, which provides a simple yet challenging testbed for language model alignment. This problem is comprised of arithmetic questions posed in natural language, with an arbitrary adversarial string inserted before the question is complete. Even in the simple setting of one-digit addition problems, it is easy to find adversarial prompts that make all tested models, including Palm 2, GPT-4, Claude 2, misbehave, and even to steer models to a particular wrong answer. We additionally provide a simple algorithm for finding successful attacks by querying those same models, which we name prompt inversion rejection sampling, PIRs. We finally show that models can be partially hardened against these attacks via reinforcement learning and via agentic constitutional loops. However, we were not able to make a language model fully robust against adversarial arithmetic attacks.